So, welcome everyone to this December edition of First Friday's acoustic seminar. And we're so happy to have three distinguished panelists talking about setup for tonal adjustments. And they are Andrew Ryan, first of all, and longtime head of the ruining shop, where he saw thousands and thousands of violins of all types through the shop. Um, he's now concentrating on new making. Robin Aitchison, who is now concentrating on new making and particularly cellos. And finally, Sam Zygmuntowicz, who needs no introduction, but I will say that usually at the acoustics workshop, Sam is the one that's asking all of the questions to the scientists and engineers. So this time we can turn the tables and ask him the questions. Um, so, um, if you haven't done so, please mute yourself, and hopefully we will have a little time for questions at the end. But we do have a list of questions that we have compiled for our panelists, and we will go through them. Probably will not have time to cover all of them, but hopefully most of them. Um, but to start, we'd like each of the panelists to take just a very brief um, give a very brief summary about their procedures in assessing instruments for tonal adjustment. So who would like to start first of the three? By the way, I've made all three of you co-hosts, so if you want to share your screen, um, you can do so.
All right, I guess I'm A, so I'll start.
Okay, go. Go ahead, Andrew.
The way I usually, Fan asked me to talk, I guess, with a more general focus towards old instruments. So when you're assessing old instruments, um, they're so varied that I like to begin by playing them. You know, if they're playable, you play them, get some assessment of them. It's good to categorize things. I like to categorize things in very simple ways. I think Sam does this a little bit too, where you might say a violin is exuberant, or it's restrained, or it's focused, or it's sort of broad. You know, just get a general sense and put a name to it. Try and focus your attention, focus your mind on what the broad attributes of the instrument are, what its shortcomings are. If it's exuberant, is it exuberant like kind of manic exuberance, or is it exuberant in a happy and playful way? I think it's good to look at an instrument that way. After that, I like to weigh instruments. I like to weigh things. It seems like a simple thing, but it already gives you a sense of what's going on in the instrument, whether it's light, it's heavy, somewhere in between. I'd like to measure the body modes, you at least get a general sense of where the stiffness of the violin is before you do anything. If you want to tinker around before you start in on the proper work, do a little soundpost adjusting to see what the instrument's capable of. We'll talk more about what the soundpost does. The thing I like to do, I have well, you can fool around with the bridge a little bit, strings, things, just peripheral things that get you a sense of how the instrument is responding to your inputs, and you get to know the instrument better. If the instrument is a player's instrument, talk to them a lot. Get a history of the instrument. Really try to understand the instrument, what's been done to it in the past. As much as you can, try to gather information, ask questions, gather more and more. The more information, the more questions you ask about the instrument and gather information in, the more successful your outcome is going to be. So that's generally my approach.
Thank you. All right. Who wants to go next? Robin, you want to go?
Yep, I can go next. So my first section looks almost exactly what Andrew just said. Um, and again, you know, with cellos, a bit like, I suppose, old instruments of any sort, they're incredibly diverse. And maybe cellos are even more diverse. And so, you know, what my first question is, you know, what kind of creature are you? And what can I do for you? And so there's I think everything that Andrew said is, you know, completely applicable to what I'm doing. There's, and very much what Andrew said, that we, you know, we're trying to gather information, get rid of any sort of variables which are messing things up, and playing the instrument. I get us, we're getting a lot of information basically back from the bow, in the way I adjust cellos. And I've got, you know, various functional objectives that I want from the bowing. It's, you know, there's often an iterative process of, you know, play, change something, keep changing things until we can get to a kind of a viable starting point. And this is another, you know, an idea I also got from Andrew, which was to have trial bridges. So we've got a drawer full of bridges that we know really well. You know, we know what sort of exactly what they do, and we've had them on lots of different cellos. And so when we're homing in on what, you know, where we think we're going, you stick some fresh feet on the bottom of the old trial bridge and fit it to the cello. And this is a nice time that you can also ask, if it's a player's instrument, you can say, do you want to try it now? Is this what you're looking for? And sort of before we start spending a lot of money cutting bridges and doing things like that. The rest of what I would say is it's I think a bit sort of very cello-y. I think stiffness is a huge issue for us, and we've got to somehow get enough stiffness or support into the sound box in order to support the setup. And again, the main issue we're going for is testing with a bow. And I often have these three pictures for cellos, a kind of an under-supported picture, an over-resistant picture, and this kind of just right picture, which of course is just right for the player we're dealing with. The under-supported is incredibly common in England, because it may not be quite so overwhelmingly common in the States, but the picture we're looking at is that the bottom strings are difficult to get into and slow to speak. And there's always this sort of, the instrument sort of catching up with you kind of picture when you're bowing. And the A string has this horrible, granular, sort of gritty, uncomfortable feel under the bow. And this is and obviously also you'd have the missing top end response. And this is a classic picture, but it can be very difficult for players to distinguish between this picture and the over-resistant, where the C string is also very difficult to get into, but for different reasons. And the top end of the instrument but in this case, is rather overwhelmingly bright and powerful and kind of trumpety. And so we're always trying to find out which of these pictures we're in order to guide what we're doing. The other thing I think a lot about with cellos is, if you like, a sort of a stiffness resistance equation. And this, I have an analogy, and I'm sure this has no underpinnings in science or acoustics. And I draw this analogy between tuning up a string and, if you like, inducing stiffness into the sound box with the soundpost. So I think that the luthiers using the soundpost in a way that is analogous to the way the player is using the tuning peg to bring up a string to a functional stiffness. So I'm not talking about pitch here, but we all know that if you tune a string down by a fifth, it's going to be all kind of floppy and useless under the bow. And my hypothesis is that an awful lot of cellos I meet, the bowed response is sort of floppy and useless in a similar kind of way. And it's fundamental to induce sufficient stiffness into the corpus or the sound box by fitting a post with the appropriate tension. And so when I look at the setup of a cello, I think, you know, you've got three components that you've got to add up to a sensible level. And that's the inherent stiffness in the sound box, the stiffness that we induce with the sound post, and the stiffness that we design into the bridge. And so that's the kind of the, I think, the cello-y stuff. And I'm happy to move on to the next speaker, if that's all right.
All right, thank you, Robin. Sam?
Yeah, well, I have to start off by saying I very much agree with the approach of both Andrew and Robin. What Andrew said had struck a chord first was wanting to get a broad stroke categorization of the instrument. So I'll come back to that. What Robin was talking about quite a bit was the dichotomy or the coordination between what comes out of the cello and what it feels like to play it. One thing I'll just comment quickly is that I think all three of us are, it sounds like, include playing the instrument ourselves as an intrinsic part of the adjustment. That's very different from the way that I learned. René Morel did not play the violin at all, and thought it was a disadvantage because you'd be using too much of your own taste in adjusting an instrument. Myself, I find it indispensable. I can adjust very quickly using my own responses playing, whereas it's a very tentative process just trying to listen and interpret what the player tells me. So, I mean, I don't ignore the player at all, but I need to corroborate what they're telling me with my own understanding of the instrument. And that being said, it's we'll get into that more later. Like, there's like, how much do you rely on what people tell you, and or what you hear? And it's quite a lot, but I find that I can't act on it until I understand it myself. So I don't take action until I kind of can bring myself to agree with the player. So it's not that I don't agree with them, but I need to take the time to understand where they're coming from personally, so that if I make a change, I can evaluate whether it did any good or not. I'll just add one more piece to add on to what they're talking about. Primarily, I'm really only adjusting my own instruments nowadays, with the occasional something else thrown in. What is different about adjusting my own instruments is I know these instruments very well. I will presumably have seen them in the past and can expect to see them in the future. One thing I do a lot of is I have an intake form, like a doctor's visit, and every visit begins with, you know, if I remember to do it, if it's not too quick, I pull out their file, and so I can see where the instrument was before, and I start a new one, which includes information like, you know, where the string heights, tail gut length, sound post position, a physical examination of the instrument. Like, you know, most of the problems can be eliminated by just eliminating the really obvious things like an open seam or the strings are low. You can, you know, the first, having taking written documentation and being able to refer to what happened in the past is just a sort of a screening, which eliminates a great deal of incidental issues right away. And once you've taken care of the incidental issues, then, you know, that usually is quite a lot of it. And also the fact that I'm working on my own instruments is I take a very a longitudinal approach to them over time. that, and, you know, and I'll also say, well, where have you been? Where are you going next? What's been happening? Has it been sounding best when it's been humid or when it's been dry? Not infrequently, people who live far away, they come in with some complaints, and then I look and the sound post is like in a quite different position than I left it. So a lot of it is just getting back to the last, you know, like it's like resetting your computer. It's like last good configuration. And then I might put, well, next time I'm going to maybe, I don't want to change the post yet, but it looks like maybe next time I'm going to change the post, or next time I'm going to play in a fingerboard. And the other thing about that is that over time, it's not like, these are not like one-time encounters. So if people come in repeatedly with a related issue each time, I can begin to smell that there is a bigger underlying issue that may need to be addressed. So I can leave it at there and we can continue.
All right. Thank you. So the first question on our list has to do with sound posts, and specifically, how great of a range in millimeters in sound post positions do you try to go for in your adjustment? Who wants to go first?
Sure, I'll go first. I would say, generally speaking, the range is, let's talk about where we start from. So if I set up an instrument, generally I'll set the posts in some sort of symmetry to the bass bar in terms of looking at the whole instrument. So if you look at the geometry of the whole instrument, I'll try and use that as a starting position. The post is standing up straight. It's usually half its thickness behind the bridge. From there, if we're talking about a violin, let's say that's 1.5 millimeters inside the bridge foot. I'm not going to go beyond the bridge foot. So if you consider 1.5 millimeters a lot, that's a lot. If you consider 1.5 millimeters a little, that's a little. I think it's important to talk about what the sound post is doing. I consider the sound post the single most important component of the setup, personally. For me, the sound post is, the sound post modifies the cross grain stiffness of the plates in the lowest body modes. What does that do? That leads to shortening the transient response of an instrument, I think. So I don't know whether that makes sense to people, but for me, finding the sweet spot for the sound post is the most critical issue in setup. You have to, that is the single most important issue. The fit has to fit. The fit has to fit because it's important to the conservation of the instrument. But if the post doesn't fit particularly perfectly, come back a year later and the top and the sound post will fit together. Same thing with length. It has to be sufficiently long. It has to be, sufficient tension to be in there. But if you fit it too stiffly or too loosely, again, come back in time and it's gonna look like it fits just fine. But the fit is the position is the number one thing. What's that, Joe?
Just a clarification. A little bit back, you said the starting point is half the thickness away from it. Is that half the post thickness, half the bridge?
Yeah, half the post thickness. So if a post is 6 millimeters, then 3 millimeters behind that.
Oh, really? And do you vary the diameter of the post a lot?
Yes. So for old instruments, you have to, I think, be willing to vary the post diameter quite considerably. For new instruments, it's it's much more standard. Everything's much more standardized because we're building things to our own criteria, and we can sort of go within an average, we'll say an average size post. But there may be conditions where you want to vary that. But yeah, for old fiddles, diameter, materials are really important. So we'll get into it a little bit more of my perspective on this categorization of materials and how to exploit them as we talk more about things. But generally, you can have like the hardest, thickest post, like what you would consider the most rigid post and the least damping kind of post, and you can have that at one extreme, and the other extreme you can have a very thin and soft sound post, and they will do, and there's lots of variation in between, depending on what you want to do. Like, for instance, a lot of French fiddles, you just want to kind of put what people would say would be a junky sort of post in there that has a certain amount of damping in it, that cut down on the sort of brightness of the fiddle, things like that. So yes, diameter and materials can be varied considerably. Does that answer the question?
Yes, very much. Although I'm curious, what particular tonal knob do you think sound post diameter turns? Or is that too specific a question?
Certainly, for me, like when they're thinner, it tends to be more ringy, and when they're thicker, it tends to be more sort of compacted, we'll say, the sound.
Interesting. Okay.
Just like if you move the post closer, you get it sort of more focused on. You move it farther away, farther south, the violin becomes easier and sort of more ringy sounding, something like that. I think in adjusting the post, there's a lot of, there are sort of, I'll call them windows of opportunity in the adjustments. So say you had the sound post very far inside and you sort of started moving the posts outward, you would find a place where it worked nicely. And then you would go farther and the post wouldn't work anymore. And then you'd come to another place where it works nicely. And if you could do that infinitely, you'd find these sort of increments of where the post actually seems to work. And then there's places in between where it's just not happening. So, theoretically, you could have a bridge that started a 38 millimeter bridge and put the post inside a millimeter, and then find the place that it works, and then find the next position where the post works and just put a wider bridge on, and then keep doing it so that the post and the bridge are always sort of working together. And in a cello setup, I'm sure this is more of a possibility. And with violins, the differences in violins is very small, whereas, as Robin was saying, the differences in cellos are huge, just in the spacing of the F holes and that sort of island of where the bridge is sitting. There's a lot more possibilities of how you can get that to work. And I think in a cello, Robin may have contradictory ideas, that how you can manipulate that area by not having a symmetrical layout to the feet. Like if you feel like a bigger bridge is going to work, you can actually put a bigger bridge on there and get it onto the bass bar properly, and then put the sound post where you want. The possibilities of sort of funkiness are greater, I think, in a cello than a violin. And I think that's a question later, like how much do you move the bridge? On a violin, I hardly move the bridge. I find this so where I want it to be, and it stays there. Maybe I tap it at, incrementally one side or another, a 1/10 of a millimeter or something like that. But essentially, it goes in where it goes, because the tolerances are just much smaller in a violin. How it functions.
So why don't we move to Robin on cellos, since you brought up the subject of cellos, Andrew. By the way, Joseph is helping to co-moderate this. So Joseph, you don't need to raise your hands. Feel free to cut in at any time, opportune time. So let's go to Robin.
So this question about how much we move it, what I suppose when I'm working with sound posts, as I mentioned before, I'm really wanting to establish what sort of tension is required by the instrument. And after that, I'm or even before that, whichever way, you know, within the customer reality, you know, somebody turns up with a cello and they want it adjusted, and you're going to start somewhere. So you're not going to start by changing the length of the post immediately. But what I'm always looking for is a position and length of the post as a starting place. And I'm hoping to find a place and a length for this post which is in the zone, if you like. I'm wanting to find that place that rules of adjustment for the soundpost will apply. You know, that if you make a particular move, it's going to have the effect that you expect it to. And because once you're in this kind of position, you've got control. If you're not in that zone, or if you're boxed into a corner, if you like, you know, I sometimes think of it as like sort of you're in a room. You want to be able to move in different directions with predictable responses. If you're standing in the corner of the room, you've not got very many options. So the first thing I'm trying to do is establish the starting place, which is going to open up possibilities for us. And so, you know, if the presenting cello has got the post in a really weird position, it's going to move a long way potentially. But we want our starting place to be not too close to the bridge. This, you know, the sort of half diameter. Maybe, you know, that's a nice place to be. And we want predictable responses from this post. And once I think you're in that starting place, I find that the movements from there are going to be, you know, often 0.5 millimeter on a cello, something like that. But you know, deciding where the starting place is going to be, and you know, the possibilities are really sort of, particularly with old instruments, can be quite sort of funky and sort of open-ended. But then, you know, I think certain instruments have, you know, they don't, you know, they have, certain instruments can present particular characteristics. You know, they'll lock up if you do one thing, you know, when another instrument wouldn't. Or they'll, you know, you'll lock up the bass or something like this, and it's going to present additional constraints. Of course, all of this is basically bowing tested and player tested. So I think the short answer to the question is, it might be a big movement to find your starting place, but once you're there and everything's the right length, hopefully it's going to be very small movements.
All right. Thank you, Robin. And Sam?
Yeah, what those guys said. Well, one thing actually I respond to in what Robin said in particular is that there is a zone of adjustment where things behave like in accordance with your understanding of the instrument. And this is something which, you know, I think it was Andrew was saying these, you know, there's analogies which don't have anything to do with the world of acoustics, but are, I've called them different things, but like metaphorically true. They're functionally true in that they describe reality as we interact with it, even if they don't describe exactly what you would find experimentally. So Rene, you know, in whose approach I sort of follow is that you should have an expectation before you make a move of what you're going to see. And it doesn't mean that you will see that, but if you don't, it means that your initial assumptions were not accurate. So that there are certain adjustments that are associated with a stiff instrument that are different than a type of adjustment that are associated with a floppy instrument. So, and often the tone that you hear, your first response is just, well, it's not good. but then it's our job to find out in what way is it not good. And so in part, adjustment is not only a process to improve things, but a process which diagnoses underlying problems and indicates directions. So what that means in practice is that, so like just in amplifying that point, that, you know, I have adjusting instruments. There is what the adjustments which inhabit the world of rationality, where you can predict what's going to happen. And then there's adjustments are just like, that's a spot that happened to work. I don't know why. And those can be very fussy and frustrating. You hit the spot and it just works that way. And, you know, sometimes you just feel like you better not touch it because I don't know why it worked in that spot, you know, and those are often things like little moves, like turning the post a little bit to try to improve the fit or something like that, which is very, very delicate. But then brought back to the initial questions, how much the post moves. So on my own instruments, the range is probably much less than on old instruments. Like, you know, there's a Strad that I adjusted a long time ago where the post really wanted to be 4 millimeters inside the bridge foot. That's something I've never done on my own instruments. I actually, for my own instruments, I never measure the bass bar because it's pretty much always going to be in the same place. So on my own instruments, if a post was in 2 millimeters, that would be like really a lot. And on my Strad models, you know, it might be a millimeter inside or something like that, or it might be a millimeter and a half. On my Guarneri models, it tends to be pretty much right up to the bridge foot. And I have some instruments where it comes out of the bridge foot and it works well there. And I associate coming further out as there's a couple different analogies for it. I mean, one is that I used to think that there's, if you think of the sound post as a pivot point, like if it was in the center, like in Collins' original models, things would be very symmetrical. Then as you go further out, things get less and less symmetrical until as the post is out, you're pushing more effectively on the bar. And even going further out, it's even more, the fulcrum moves even more that way. Another way to look at it is just that you're creating more asymmetry in the modal shapes. Just in general, I consider that a stiffer instrument will work better with the post further outside, other things being equal. How much further outside just has to be determined experimentally. One of the difficulties with wooden sound posts, adjusting wooden sound posts is very much an art because you don't cut a new sound post for every move. It's just not practical. You know, in the privacy of, you know, in my own time, I'll often cut multiple posts for an instrument just to experiment. But in real time with a client, I just, you know, it breaks the flow too much and it's too time consuming and too uncontrolled. So you move something and you're changing multiple factors at the same time. And it's very hard to be specific about what factor you think you're changing. Just as an aside, the carbon fiber posts, which I don't routinely use, have been extremely interesting experimentally from what they've taught us. At Oberlin, the last time we had an Oberlin, MJ ran a couple of experiments based on some of these ideas where they used the carbon post to experiment with moving the post pretty radically east and west. And we calculated how much, you know, for a millimeter of motion east or whatever, how much effective shortening or lengthening of the post you're doing, because and we could calculate that. You could just sort of calculate the slope and then come up with a number. And it was basically something like for every millimeter, it's about 1/4 of a millimeter in length, roughly, on most instruments. From that, I would it confirmed my idea that position matters, as Andrew was talking about. However, something else, like with my cello clients. I don't do as much cello as, you know, it's a sideline for me, I guess. But a number of my better cellists have now put in have carbon posts and have managed to get the tools themselves. And it's been really interesting to me to see what they do on their own instruments without adult supervision, you know. And some of the things they're doing is that they're much looser than they were in the old days. You know, when they're just adjusting to their own tastes, those posts are quite a bit looser than I would have associated with wood back in the day. They're quite a bit further back from the posts. I think that's partly because the main person who installs them here has that as his default position. And the other thing is that very tiny motions, like, you know, like half a line, which is like, I don't know, very small, whatever that word is, amount of change is very perceivable to them. So so I think I do have an awareness that these tiny moves might be just, especially on the back, I consider that like tiny moves on the back to be more about micro adjusting tension than about position. And I think the position on the top is more crucial. I'm wandering a bit here. Is that a good place to stop?
Just to get back to the original question, you talked about the space east and west. What about north and south? How far do you?
Yeah, I
Typically
personally
put it
am
in
not
terms
as
of-
concerned about that. I would agree that on a very ringy, maybe edgy, super active instrument, I would be more likely to put it rather close to the bridge, as close as a millimeter or so. And habitually, I don't go further back than 3 millimeters. One of the things I find actually, you know, the north and south useful for, this was actually a insight that came from the world of acoustics, which I hadn't thought about before, which was that you move further away from the bridge, you're constricting the area of motion for the low modes. And actually, I found that being further away from the bridge is somewhat helpful for wolf notes, contrary to what I would have thought. I would have thought that being closer to the bridge would be more supportive of the bridge and would be better for wolves, but actually I think that the opposite is somewhat true, is that when you move it further away from the bridge, you're just narrowing the active area of the top a little bit, which can be helpful for that. So that's north and south.
Thank you.
All right.
Next
Joseph, you
question.
want to move on to the bass bars next?
Sure.
All right. What do you find are the effects of a stiffer or less stiff bass bar? Do you vary the longitudinal profile as a tonal adjustment? And let's start with Sam.
Okay. Well, I'll tell you what I'll do, but I mean, bass bars are very confusing. There was a long MaestroNet thread once that went on for many pages about what people do with their bass bars. And I think the entire thread was basically devoid of any conclusions about what does what. There was a lot of, well, I do it this way, but there was almost nobody who said that doing it this way or that way was different than doing it some other way. So on the one hand, bass bars seem to, like, it's important to have a bass bar, but you know, it's not always clear what the details of the bass bar do. And then I'll contrast that with my own experience to some extent. I'm very interested in the varying, not just the overall size of the bass bar, but the portions of the bass bar. There was you know, the Becker method of portioning it was like, you know, the high point being basically at the middle of the bar, middle of the instrument, and then you divide them, you know, those halves. So there's a smaller lower half and so that basically the high spot is above the bridge, according to that. But anyway, so you have the middle, you've got the quarters, the eighths near the ends, and the ends. And so I have found that the from the quarters to the ends is very sensitive as far as the intensity and the treble sound of the instrument. That like you do see a style of bass bar cutting, I consider it sort of an older fashioned style, which is high in the middle and quite swoopy. and my association with that style of bar is being a little boomy and a little empty and not so focused. And that, one quality in instruments that used to plague me more, does less now, was what I called a gummy characteristic, where, when like there's the engagement, the transient on the G string, like notes on the G string, when you hit it, does it have like a positive, like, ga, I used to call it a click. Does the bow, does the string snap right in? And then that's followed by what I used to call the boom, like it's a ba, you want both of those things. And then sometimes instruments, you just feel like you're like running in lead shoes or something like that. Like it just doesn't speak quickly enough. And one of the interventions, I haven't done this as much recently. Either I'm not, either I'm doing better or I'm more resigned to my fate. But when I put in bass bars, I often found that that stiffening the ends just made things cleaner and made the brighter, cleaner. Yeah, and well, there's more to say about bass bars, but I do think that, well, here just quickly, because I think it's interesting. There's sort of been an evolution in people's thinking about bass bars. The earliest thinking, was that, it's that it's just sort of keeping more of the top vibrating together, so you get more monopole, whatever. That was the first understanding. That was like an improvement over nothing. And then I think that I think Norman was introduced me to the idea that actually the bass bar does that at low frequencies, but at higher frequencies, it stops moving because it has so much inertial mass that there's not enough torque for the raised bass foot to push it, and then it starts being more steady, and then the post side starts moving more. So I would call that like the second level of understanding of bass bars. But something that came out of George Stepani's work when he started to do these band averages going up quite a bit higher in frequency, where people tend to not study them so much, that we saw quite a lot of, George, you can correct me if I'm wrong about this, but my recollection is that we saw quite a lot of activity in areas, high frequency area, away from the island, out towards the ends of the instrument, in areas which we weren't used to thinking of being active at all, especially not for that. And so I think a third function of the bass bar is that that like you're hammering on the bass bar, like, with the bridge at high frequencies, and it's not moving a lot, but it is transmitting that high frequency to the end of the instrument. And the end of the instrument this is the way I look at it. I can't totally say that this is the case, but like if you look in the Strat 3D project, George has some I think we call them band average movies, and you can start to see the patterns. And at low frequencies, things are where you'd expect them, big areas. And then in the mid-range, you see sort of what we now expect to see a lot of around the F-hole wings. But then as it went higher, it moved away from the F-hole wings out towards the extremities of the instrument. So I think that is a highly understudied area of the instrument. And I think the bass bar is important for that.
All right. Thank you, Sam. Let's go to Andrew on this.
Sure. Yes, and varied profiles. I think one should be open to varying profiles. I have some bunch of templates I made in the past, which all have different profiles. High point at the Mensur, high point in the middle, composite where the high point is sort of broadened. But the idea of the templates was to think about distribution of stiffness in the bass bar. What are you trying to get the bass bar to do? A little bit like what Sam was saying. Okay, you have a central section, you have the ends. What is the function of each part of the bass bar? For old instruments, I think you also have to be willing to experiment with materials. And I talked to the Michigan violin makers a couple months ago about bass bars, because the opportunities or the if you have an old instrument, the opportunities of altering things are the window is very small. There's very few things you can change. You can't change your arching. You can press the arching, but we'll say that the arching is essentially fixed. The varnish is fixed. The wood is fixed. Basically, you're limited to bass bar. Maybe you can add a patch, soundpost, neck setting. It's a very limited opportunities to affect change. So, for instance, if you have a very stiff top, what are you going to do about that in an old instrument? You can't regraduate it. It is that's not a possibility. So you have to find other ways to alter the behavior of the top. Possibilities are the shape of the bass bar and the materials that you make the bass bar from. You pick materials that, so if you had a very stiff top, you'd probably want to pick heavier materials, softer materials to sort of bring the resonance of the top down. The shape of the bass bar, I think Joe talked about this 30 years ago. If you make a bass bar twice as wide, it's twice as heavy and twice as stiff. If you make it twice as tall, it's twice as heavy, but it's 3 times stiffer. So the whole idea of how you're distributing material within the bass bar determines how it's going to behave. So I think these are all possibilities of manipulating the bass bar and getting the top to behave the way you want it to. In an old instrument, I think, again, it's, Sam was talking about, sort of high frequency stuff. I think in old instruments, it's like you're trying to get very fundamental things to work, generally speaking. Get the lowest modes to work well, because the possibilities of altering the other stuff is you're very limited in what you can do. So it's the shape and the materials.
So a quick,
yeah,
just one sentence answer from you and Sam. What would be about the lowest bass bar you'd put in a normally arched instrument and the highest?
Right. So for me, just the bass bar, the minimum would be probably about 10 millimeters, the maximum 12. If you can, I usually measure it with the top, but that's not.
I do too, so use the top numbers. Otherwise, I have to do math.
Yeah, I usually count for something of what the top, the thickness of the top in it.
So about 2 millimeters.
What's that?
So it's about 2 millimeter range.
2 millimeters difference, yeah. But so for instance, if we talk about distribution, so you could have the highest point just a point, like you see a lot of old, Sam was talking about old style bars where they just come up to a point like this, or you could come up and just have this long, sort of very long area of 12 millimeter height before it goes down. So those are functionally very different distributions of material, and so I think it's important to think about what you want the top to do, how you want to change the behavior, if there's a behavior of it that you're trying to do. So this goes back to the very beginning, like gathering information about an instrument. Is it exuberant? Say, I'll use the exuberant instrument example again. So say you had an instrument that's just sort of just wild and sort of untamed, just too much vibration, too much sound. So you want to restrain that somehow. So you may decide, all right, I'm going to add some more mass. Just simply add some mass to the bass bar to rein in some of that behavior. This is where gathering that information ahead of time really helps your decision-making process. And then once you decide that, okay, so how are you going to distribute that mass within the bass bar? Is it going to be this, make a wide bass bar, make a 6.5 millimeter wide bass bar and 10 millimeters high, or you're going to have 5.5 and 12? Those are very different scenarios of how the bass bar is functioning. And I think if you're categorizing in the beginning, then you can have a better idea, okay, what is it? How am I going to use my materials and the form to alter the behavior of
Andrew, could I ask you a question?
Sure.
So I was really interested to see the fistful of templates. So could you give an example of two different styles of bass bar shape and when you would use one rather than the other?
Right. It's been a long time. So that example of let me pick one here. So here's one where the high point is on the Menzura. So that's just my sort of standard Becker profile, but the high point is on the Menzura. So if you think about the most vibrating area of the top, or the most bending area of the top, as far as at least the bass bar is concerned, generally is in that island area, between the upper part of the F-hole and the bottom part of the F-hole. If you look at the modal behavior there, that's pretty much where it's bending. So if you're trying to restrain this exuberant vibe, then you might say, okay, I'm going to put a lot of mass just right there, so it's both stiffer and heavier. So I might make a wide bar that's tapered, which has a long sort of, most of the mass and the stiffness of the bar is right there, and then I'm going to go away from it. So that might be a way I would respond to a particular instrument.
And Sam?
Yes.
And Sam, is 2 millimeters about your range?
Yeah, especially in the middle, I don't vary things that much. One of the things about new making is that it's just the range of what I do is very narrow altogether. There's a lot of what I do is kind of boring in that it's very reiterative. I do it similar. But
you on your, for example, your high arch Strad models put in a lower bar than your flatter Guarneri models?
Yes, probably yes. I mean, I'd love to hear for some, I feel due for some more modal analysis or something, because I have a lot of questions about the bass bar, which I feel is insufficiently answered.
Agreed.
So I don't vary it that much, but like through the top, like a low bar for me would be 14 and a high bar 15 would be a lot. It's just not that much variation. I do probably more variation at the quarters, because by the time you're like 14, 15 through the top, you're pretty stiff, so you're quite stiff there anyway. But whereas like further out, you're lower down, so a millimeter difference at the quarters is a lot more than a millimeter difference at the Mensur. I mean, go ahead.
Oh, sorry. I wanted to jump in and say something a little bit about standardization of form. So in new instrument making, yes, we have a lot of sort of, like you say, it's reiterative. We have our standard ways of doing this. And I think this is an important consideration in the way I work, or a way I would recommend people work, is to have standard forms and alter materials. So if you have a standard form, you say, I always make the bass bar this shape, and then I vary my materials, you're much more likely to have an understanding of what you actually changed. Or you say, this is my bass bar stock. I always use this particular tree. This is the one tree I use, and I'm just going to change the shape all the time. So you need to have some criteria upon of what you're manipulating. Establish your criteria, whatever that criteria is. Shape is the criteria, form is the criteria, material is the criteria. That allows you to gather information that's useful about what you're doing and how you're making changes. Does that make sense? Sorry.
I just want to throw out, I'm sorry, Robin, you're just a tidbit. I was revisiting a lot, like the Strat 3D instruments, particularly the Wilmot and the Plowden, had very old setups when they were first tested. And so we have some tap tone tests, for example, from 2006. And those instruments were subsequently restored, the Wilmot very heavily. And the Plowden got a much more normal bar. It had a very low bar before, and the Spectra got a lot choppier looking, spikier, and it was a smoother, more evenly distributed Spectra before when the bars were low and the instruments were so anyway.
Okay, Robin, go ahead.
Yeah.
And then I want to actually ask the same question about violas because they kind of go between the cracks here. But Robin,
Okay. Cool. So the first thing, a bass bar and a cello is about 10% of the mass of the entire front. And, I look at this and I go, wow, well, that's got to be worth optimizing. So, it's something definitely that deserves sort of a lot of energy and pursuit. I really love Sam's Gluey project that he did many years ago and wrote up. And I find this a wonderful tool for evolving bass bar design, because you can make a bass bar how you think it should be, or how you've decided a bar for a particular model you're making is going to be. And then you can stick extra stiffening, in any position along the bar on the outside of the instrument, in order to test your hypotheses about what might be a good idea or what's not a good idea, or what's going to benefit this instrument, or just generally the behavior of bass bars on this model. And so there's always this thing about, to what extent are our experiences particular to one situation, and how much can we generalize? One strange thing is that I tried, one thing I did try was extending the bar, out beyond its normal position at the ends. And so I actually have, some models where my bar goes closer to the top than the bottom, and another model where it's closer to the bottom than the top. And it seems to work for the model. And there's one of my models that I copy. I actually opened the original instrument to do a repair, and I found that the bass bar in that instrument was pretty much following the evolutions that I had made on my model in terms of its shape and its differential position at the top and bottom of the instrument. So I think it's nice to open up to those things. In terms of, what we can be sure about, I don't think I can say, there's a few things that I feel I can describe experiences that I think would definitely be applicable to different situations. People have talked about this bar, which is kind of straight, flat in the middle, and then it's scooped away in the ends. And I use that kind of bar on my Strad model. And I did discover that one time I scooped a bit too much, and the cello was impossibly and irreversibly sort of big in the lower register. And this made sense to me, because I'd introduced this, we've got a bit of unsupported mass in the middle of the bass bar there. We've got quite a chunk of mass, and it's not being sufficiently well connected to the ends of the bar. And so I think you can be fairly sure that if you take too much wood out of the quarters, then you're going to have that sort of situation. There's also this issue about, where you see a lot of, for example, there is a bass bar design. You see it in quite a lot of old cello bars, and I think all the Hill violin bars and things like this, where the high point of the bar is well down, at the mensur or even beyond. And so the bar heights are rather low in the area around the upper corners of the instrument. And my experience is that this kind of design will take excess harsh brightness, sort of, you can get aggressive insistency to your upper register. And I think that this design of bass bar is designed to address that. And this area of the bar around the upper corners of the instrument, I do associate a lot with upper frequency responses. When I say higher frequency, I mean played frequencies. What Sam said about the ends of the bar and intensity, I think is, I've sometimes added height to bars in those areas, and testing on the outside and then replicating on the inside. And I've sometimes found that very constructive, though I was very unclear about its effect. So thank you, Sam. And there's only one other thing. Okay, there's this issue of bar density. I've sometimes found that using denser bars can give cellos a better sense of the sound, a better sense of presence in the space, which can be really good. A real caution about using denser wood is that, if we finish a front, which we consider very stiff and very bright because it's got high tap tone frequencies as a free plate, and then we stick a heavy bar in it, if it's a light front and you put all that mass in it, you can discover that the stiffness of the plate, which was perfectly adequate to support its own weight, because it was light wood, isn't sufficient to support the mass of a heavy bar if you use denser wood. So that can be, that seems to be a little bit of a corner that one can run into.
Well, certainly less dense material seems to be more susceptible to differences in mass. Like, for instance, if you have a very light top and you put a heavy chin rest on it, it's, in my experience, that effect is much more profound than you have a normal density or a higher density top that may be just as stiff, or all things otherwise being equal. It has a more profound effect, like you're saying. Mass somehow swamps all other effects.
Completely agree. And this actually brings me to another situation that I've had. I was trying to copy this Mara cello. It's a well-known Strad cello. And this is a very lightly built instrument. And I've really struggled. I'm still struggling with it. But one of the things and it's still the prototype. And whenever I have some spare time and I've dreamt up another thing to do to it, I do it. But one of the problems with it has a fantastic, lovely, open, nutty bass, but the upper register was a bit dark and narrow. This real narrow dark. It was brilliant and projecting and edgy, but it was not nice. It was narrow and ugh. And so in the end, this cello also, which is very light, as you described, absolutely hates mass. Anything you hang extra mass on it anywhere, and it hates it. So it's really super sensitive. And so this is really hooking in with your observation about lightly built instruments. So I took the front off and we took out the bar. It wasn't particularly dense wood, and it was pretty chunky bar. And I fitted an even stiffer bar, but in lighter wood. And that was, this bar was 29 millimeters high now, measured on the inside, not even through the cello, which is that's kind of off the spectrum.
Eiffel Tower-ish.
But it was definitely, obviously it was lighter wood, so you have to compensate for the less strength, less stiffness in the wood. So and this bar did definitely, it's definitely been a good move. The upper register is definitely less narrow, definitely less dark, and things are definitely working better. So that was, you know, a kind of an, but I think after that, I've pretty much exhausted all the things I feel confident about to observe in bass bars. There's one kind of question I have for the panel. Since I love tinkering around so much with the heights of these bars, I started just finishing them, you know, square at the top, rather than this lovely, you know, these beautiful sort of arched shapes we give our bass bars. And because then you can always stick an extra bit on any way you like without, you know, having to plane too much wood away. And so I have a question, you know, does anybody have a good reason not to do that?
I don't know if it, well, I don't know if it qualifies as a good reason, because I thought about doing the same thing, and it seems eminently sensible to either just be able to just put a lining strip on top, or if you need to just plane down a little bit and stick another bit on it. It is interesting to me that all the good shops do taper the bars. And I always have, what's that?
Apparently Vatterlow's shop did not.
Ah, okay, well, that's a little outside my experience. You know, the Saucony influenced people all did them. And I have an alarm system. There's something which I call CVT, the collective voice of tradition. And there, you know, we burn incense on the altar of CVT, and if you don't, the angry tradition gods will bite you later. So the fact that most of the good shops have been doing that makes me suspicious that that they are onto something. This doesn't qualify as a reason. It's just so that's one thing. But there is something else, which is that if you picture, you know, the top is at various modes, it's moving, and it might be large sections might be moving, or one section might be moving. So if one section is moving, you know, out of plane with the other, the bar has to twist to follow that section. And so it has occurred to me that you very possibly want the bar to be stiff, you know, by being skinny and high. So it's strong as far as deflection out of plane, but not too rigid as far as being able to move with the deflections of the top, right? And I even remember Oliver Rogers finding that there was some mode, he had no explanation why, where some section of the bar just moved sideways. Colin, have you seen this in your models at all? Oh, Colin, you're muted, I'm sorry.
I'm not muted. Yeah. The amazing thing is that when you see the full dynamic modes, like George and I were involved in this laser thing in Aztec, where we did the sort of thing that George Bissinger was doing as well. Mm-hmm. But absolutely amazing when you see how much sideways movement there is for all modes at all frequencies. Mm-hmm. Not surprisingly, think what you're doing when you do a tap. You're knocking the instrument sideways. And so, no, you're bound to get, for example, the island area tending to move sideways compared to the rest of the body of the instrument. As it's amazingly complex. Every way that the violin you can imagine, and the island area in particular, can vibrate, it does. At some stage, if it be allowed, I'd be delighted to show a screen print of the paper I wrote, in fact, on the island area, in which it shows, I think, dramatically the importance of both the soundpost and the bass bar and the bridge on the behavior in the island sort of area between round about just below 2000 hertz up to about 4 kilohertz. And what came out of my modal analysis was that basically you need a balance between the soundpost and the bassbar. And they operate in slightly different ways because the soundpost is a point constriction. Whereas it stops vibrations at its ends at high frequencies, whereas the bassbar is a lengthwise one. So they act in rather different ways, but in particular, the bassbar certainly changes the modal shapes and in the upper bout and lower bout over the whole frequency range. It's not just I'm in the island area.
Yeah, so Colin, I think you just volunteered to give a future talk, so we will definitely schedule it, okay?
Yeah, okay. But
So-
I mean, it might be instructive just for a moment at the appropriate time, if I can do this just a screenshot.
But anyway, to look back to
Later
your
on.
question, Robin.
Later on.
Yeah, I think we should move on,
Later on.
Colin.
Oh, I agree.
Okay.
I'm listening to the makers because that's what
Okay.
it's all
So
about.
let's move on to because you talked about the triumvirate of the the soundpost, the bassbar, and the bridge, and so let's move on to the George. Okay, let's move on to the bridge. Okay.
Before
Just make a very quick point.
Okay.
We're talking a lot of the time about the stiffness of the bass bar as a object under static forces, whereas actually when you look at it as in a dynamic sense, the area of the bass bar under the bridge foot can become extremely mobile at some frequencies because it's at an antinode of a mode shape there. So I think this is a mistake to be fixated on the static behavior of the instrument. Bear in mind that the kind of thing that Colin is talking about, the interaction between the 2 feet, one dominated by the effect of the soundpost and the other by the bass bar. It's not just the mass or the stiffness of the bass bar, it's the mode shapes that occur there, which is why when you go up into the transition hill, you start to see more mobility around the bass bar.
Well, I think this was Robin's point about materials and the Mara cello, that explaining that he used a lighter material and a taller form. It wasn't about static stiffness, it was about acoustic stiffness and the acoustic behavior. I think that was his Robin's point.
And I just wanted to loop back to you for 1 second, Robin. You mentioned that the area of the bass bar between the upper corners was influential in
Upper frequency.
Upper frequency. So in what way? If it's higher, does that enhance or inhibit?
Yeah, definitely. To me, this is the area. If I've got a cello and I want more from the A string or more from the upper register altogether, and I suspect that I find that the best way to approach it is with the bar, because of course you could approach it by modifying the stiffnesses of other parts of the instrument. But if I'm going to tackle it with the bar, that's where I go for.
But would you make it higher to get more intensity?
Yeah, higher to increase to open up the top end of the instrument more.
So you might wind up with basically the higher is the emphasis of mass in the bar or stiffness in the bar higher up in the instrument.
Well, or just more symmetrical, because you know a lot of bass bar designs are sort of biased down the way. Yeah.
I see.
So in a way, you know, if you think about what I call the hill design, where the high point of the bar is lower down the instrument, versus a symmetrical bar design, then the symmetrical bar design, in my mind, is going to give more brilliance and power to the upper register than the hill one.
Well, that suggests an excellent experiment, kind of a gluey one we could do at Oberlin. Let's take this hypothesis of stiffening the bass bar right there, and then we can measure how it changes. That's a really good observation.
So, Joseph, you want to move on to the bridge?
Sure.
Yeah, let's move on to the bridge. The first question is not purely technical. It's has to do with your shop practices. To what extent is bridge tuning and the bridge mass an integral part of your adjustment process?
Why don't you start, Robin, as you've been.
Okay, so as I described earlier, I use, if I've got any uncertainty about bridges, I use this trial bridge system. And so you put your known quantity, tried and trusted, there's lots of, different models, some different French bridge models and a collection of Belgian bridges that haven't been used on various cellos and we know what kind of creature, I know what they are.
Can I just ask you to specify, what do you know? Do you know the resonant frequencies, the mass, or just something more metaphoric?
I know its effect from a playing point of view. I don't know anything. I have to confess, I don't know about its frequencies. I do know its mass. Very accurately. And also, I know all its measurements, and I absolutely there was a lovely quite short article, I think a Rogers article, a finite element analysis of different bridges, which I find hugely influential and revealing. So basically, I've got these different bridges and. I try, there's my hypothesis, we put this one on and okay, we like that, but we'd like it to be a little bit brighter, or a little bit darker, or we want to just match that. And so then I've got something with all the masses and stiffnesses and design to match to. And so I'm afraid that's how I go at it. And no frequencies tested at all.
I'll jump in with Robin to concur with Robin. When I was at Runings, I actually had a board for violins. It was I had 9 Dijac bridges. These Dijac that have the adjustable feet.
This is where my idea came from, Andrew.
Oh, did it? So I still do it. Like, this is a bridge I have in my shop that's basically the standard height. It weighs 1.8 grams. I know the frequency, but it's just a Dijac bridge, so I can stick it on anything. But when I was at Ruining, I had 9 of them, and they were set in from lowest frequency and lowest mass to highest frequency, highest or lightest. Basically, you had 9 possibilities. I'm not describing it properly, but you had low mass to high mass and low stiffness to high stiffness. So you could just take these bridges off and just stick them on the violin and see, does this violin like more mass? Does it like less mass? Does it like more stiffness, less stiffness? And it totally gave you an idea. Like, within 5 minutes, you get, okay, you have a rough idea of what I want to do, what I should do with the bridge. So just to support that. And I'll make another case. Robin and I worked about, God, it must be 15 years ago that we did the cello bridge together. We designed a cello bridge from our English model, which I still use, but I suggest everybody to pick a model of bridge that for violins the scope is much smaller than cellos, but I basically have bridges made that are essentially, for me, finished. I hardly ever touch the cutouts of the bridge. I fit the feet, I fit them as low, basically to finished. And it's like 2 or 3 knife cuts and that's it. But I have them in a lot of different materials. And I sort them by material. So you can say a lot about the difference, or you can, you decide what the bridge needs to be and what materials you want to make it from. Again, more mass, less mass, higher stiffness, lower stiffness, whatever combination you want, and then you stick it on. And if you want to change something, you're changing the materials, not the design. So the form stays, the materials change. you could do it the other way around if people wanted. You could always make your bridges out of the same piece of wood and change the form. That's a little harder, but so for me, it's the form always stays. And then I vary the materials to get the performance that I want different. And this is sort of more important for old instruments than new instruments, though they can do the same thing. Sorry, I interrupted your thing, but I just wanted to sort of jump in as supporting it. Carry on, sorry.
This was one other thing. I mean, I'd said most of what I was going to say, but I find it very reassuring when I make a new instrument that, you know, when you set it up, I'm going to put a bridge on it that's a no, you know, there's no questions about this bridge as a wild card in trying to assess or analyze or progress the development of the instrument. You know, you absolutely know what you've got, and that's, I find it's very reassuring to get rid of that variable in a newly made instrument.
Mm-hmm.
Sure.
And Sam?
Yeah, well, it's, I mean, one thing is that I think that like most shops have a basic bridge design, and those bridge designs tend to have sort of intrinsic tunings. If you use conservative material and you cut a bridge according to that style, you will get a certain type of sound. So for example, the Morel bridge is, you know, pretty thin, not a lot of wood on the head, somewhat high legs. And that's still what I follow. And I do routinely check the weight of things, because sometimes because of the material, just like they'll be looking pretty good and you'll come up with a bridge and it's like you're looking for places to take to get it down below 1.9 or something like that. It's just stubborn. So I would say there's almost no circumstances where I really want to cut a darker bridge personally. However, I mean, what's that?
What do you mean by darker?
Well, I mean, I almost never want to put a extra low tuned bridge on an instrument. I mean, there's almost no circumstances where I want to make an instrument less brilliant. But I recently have someone who is not a regular client who bought an instrument of mine on the secondary market, and I put a new bridge on, and he's not thrilled. For him, it's a little not as malleable and not as warm. You know, I shouldn't be too rigid about it, so to speak, but I do check the tuning, not every bridge. I mean, I usually find, like, you know, I pull my Aubert Deluxe out and put it on there and check the weight, and it's usually, you know, things are fine. In more demanding circumstances, I will go back, or if I'm troubleshooting, then I'll go back and check the tuning. And there are, like, sometimes with a client, this works very well on cello, like a cheap trick, like, you know, you're trying to brighten it up a little bit. You just take your knife and you just widen the bevel on the side of the bridge, and then their eyes go kind of wide afterwards, you know. The second cut gets you in trouble. Yeah, so I mean, I'll do some sort of standard kind of tuning. I will say this is not in the nature of a plea for further work, that there are other areas of the violin bridge in particular that are very underexplored in my view. You know, because the bridge is moving all over the place. I've seen some, you know, some modal analysis of bridges and some finite element things, and they're doing all kinds of stuff. And so, for example, on the instrument, I can't remember where I saw this model, but doing modal analysis on a bridge or a finite element, I'm sorry, I don't remember where I saw it. There was almost nothing where you saw really clean looking rocking of the top back and forth. And so in a way, the tuning of the rocking is to some extent possibly a proxy for other things that are going on. It's telling us that, yes, the mass is less. Like something I saw a lot of is like what we were calling gorilla arms, where like if this is the bridge and that's the heart there somewhere, where the bridge was doing this quite a bit. And I also saw very little of the twisting. So for example, like in a typical tuning of a bridge, you know, the other modes that you see, I don't usually try to tune them, but they must be important. Like the first one you see, the first bending over like this, which is usually like in the 600s or so, does something. And then there's something around 1700, which I associate with twisting. And then there's something which wasn't really discussed earlier, which I consistently found, like around 2800, which turns out to be this gorilla arms motion. And then there's the rocking around 3000 plus. And then there's all kinds of other stuff. So I have not sufficiently experimented with what those other motions are, and it must be important. For example, George, you did a modal analysis on the giant bridge. I think it was a giant bridge or maybe it was on an instrument at Oberlin. But one thing which we saw quite a lot of was if this is the heads up here, and then there's the waist, and then there's the thighs, or whatever you want to call them. There was quite a lot of like the thighs bending. Which kind of makes sense. It's like if the bridge is trying to ride this, you know, there's all this activity at the top of the bridge, and then it's kind of got like its suspension system down here. So like being able to move on the thighs is helping it like pump on one foot maybe. There was one time where we tried thinning the thighs quite thin, and I thought it was actually good. But it's, you know, it's like, it's one of those things. It's like, you know, the cost of R&D on the violin family instruments is very high, which is what's cool about the gluey system if you can do it. Because like, who really wants to make 5 bridges or destructively alter one of your bridges and then have it ruined and then make another one? And some people do, and hats off to you. And so anyway, there's some thoughts about it.
I think that's something that FEA models will increasingly explore at a much lower cost in terms of labor.
So,
I mean, like you say, we don't know it must be important. It may be important. The other mode,
To answer the question, I think bass is more important than tuning.
Yeah, I'd go with that, because a heavy bridge I've never had luck with. And I haven't always checked the tuning, so I don't exactly know. And
I think the tuning is like, you get it to a certain point and you're good.
Right. Right, because you make
maybe that's the same way, but they're in opposite directions.
Right.
You gotta get
I mean, there's a couple of related issues. One is that you know, just making a bridge in the first place, we have all kinds of constraints about arch distortion, how much wood you have to work with, and how much you have to take off one foot, and then how much wood how low the heart may sink in the bridge, and you know, so there's practical things that cramp your style about where you'd like to put the things, unless you make your own bridges, which is probably smart. And the other thing is that you lower the bridge at some point, and everything's a different, you know. Yeah. Anyway.
Yep.
Yeah. So let's go to some more specific questions about the bridge. One of them is. I think we talked a little bit about this, but let's visit this. Is do you vary the bridge position during adjustment, and if so, how much?
I bet Robin probably does a lot, because I'm guessing, because cellos and violas, I'm just jumping in here. There's quite a lot of variation in string length and playing strength, and quite a lot of issues about stretches and ergonomic issues. So it's quite common on cellos and violas for the bridge to be very much further from where it was probably designed to be, or at least not between the notches. And on my own violas, like, you know, I'll make something and it was designed to be 22.3, and then after a little while it's now 22 because I'm trying to help out a little bit. So that's something that happens sort of incidentally, and then you just deal with the tonal fallout. But it is quite interesting and quite sensitive. So that's something I don't often work with, is north and south. However, on a couple of cellos that I worked with, you know, moving the bridge from 40.5 to 40, one player did not like it, because it just seemed a little more lightweight and less focused. On the other hand, sometimes moving it forward, like if I had to generalize, I might guesstimate based on, I think, experience. Is there a category for what that phrase? I think I've observed, but I couldn't swear to it.
Somebody told me once.
Right. That you move it further, it's a more flexible part of the top, and the response is a little faster. And you move it further down on the instrument, and the response is a little slower, and maybe things are a little more focused. I don't know if that corresponds with any of your experiences.
So also, Ciccone said in his book that you can move instruments up the instrument, but it's dangerous to move them down.
Right, I remember that, yeah.
Yeah, and you know, for me, model by model, you know, essentially the bridge position is established on my model. I very rarely change that. But this Ciccone thing, which, you know, I never met anybody who explained it, but I wonder, I have a kind of a hypothesis that, you know, basically if you move a bridge up an instrument, you presumably move the post with it. And you move the post to a narrower part of the back. And you probably also, because you're probably going to move the post due north, you're not going to swing it in. It's going to end up closer to the ribs. And I know this is one thing Renee was, you know, at the setup workshops, people talked about this thing Renee was talking about, and various other people, so that the distance of the post from the C rib is very influential. And I've certainly found that to be the case in cellos. So I wonder whether, you know, we have to think that when we move the bridge up and we move the post up, part of this is the, you know, or maybe a big part, maybe not, is the position of the post on the back. And I had one experience with, I was setting up a very large cello. It was a Milan school cello, a Tesoro school, I think. And it had a very low stop, or, you know, it was a pretty weird shape, basically. And this thing wasn't working at all. And it was very, very under-supported. And I saw it and I thought, oh, I bet I can crack this. I'll swing the bottom of the post out towards the C rib. And when I got the setup off and had a look through the end pin hole, somebody had already done that. So I thought, shit, what am I going to do next? So I actually angled the posts up to the instrument so that, you know, it was doing everything it possibly could to get closer to that C rib. And you know, I said to the guy, look, this post looks highly unconventional now, but it works, and it really did work. So that, you know, that's you know, a dimension of it, maybe. But and of course the answer to whether I move my bridges, the only time I move bridges when adjusting is as a pseudo soundpost adjustment. You know, sometimes it's easier just to move that treble foot 0.5 millimeter to find out whether you should do something, whether you should do that with the soundposts, because it's easier and more reversible. You know, they're sitting there right in front of you, and but that's and of course, you know, maybe this is an area. You know, I know that there have been acoustic theories about, you know, balance and the position of the bridge north, south, up and down the instrument. I have to say I haven't been there. So
actually, just a question for you, Robin. Sorry to jump in there. So, you know, you fit a bridge, you're very careful about your bridges, and then they sort of inevitably spread so that they're wider. So do you have any observations about what happens as the bridge spreads?
Yeah, it sounds crap.
What's that?
Sounds crap. No, there's a story here. You know, we've had this a number of times. Cellists have knocked their cellos over onto the bridge on a carpeted floor, and they're very distraught because the instrument's sounding awful and they think they've cracked something, and they travel for hours and hours, and they turn up at the shop. and I squeeze the feet in together, and that's the end of the story. But it's if you splay the legs on a cello bridge, you can make a good cello sound like an orange box. And you can also very susceptible to bridge foot buzzes, which are a nightmare. Yeah. So, and this is just, you know, but at the same time, it's you know, we spread the legs on a bridge before we fit the feet, but it's kind of scary. Fitting, you know, when you set it, you know, I think I've had the edge of a bridge dig into the varnish, you know, where, you know, you really want to put that leg spreader back on before you put the strings on the cello so that you can get those legs out and you don't damage the instrument. But yeah, it's a real issue, particularly with Belgian bridges.
Right.
So, and it does, it's the how the feet are sitting on the instrument is incredibly, you know, has an enormous effect on sound. The number of times people come in and all I end up doing is, you know, the legs have got a bit too, you know, ridiculously splayed, or the bridge isn't standing quite straight, even though I've given them a gauge. And that's the only adjustment they need. So you had some idea about trying to condition the legs of bridges to stop them spreading.
Right. You can kind of restore bridges too a little bit.
Oh yeah, definitely. Yeah, definitely.
but that was based on the I started thinking about that with the Milestam bridges that have the little bridge, the little cable
taken from the banks. It's a copy of there's an English period where the arching's quite pointy, but they definitely needed a bright bridge, you know, a pseudo Belgian style bridge. And so
do you have an opinion about those with the little tongues? Do you think it makes
sense? Actually, because I've had to set up some of these English cellos, and they're very strong cellos, so you need a lightly cut bridge to go with them. And they're dark cellos, so you need a Belgian bridge or a very bright bridge. And I've actually ended up, I drill a couple of holes in the legs of the bridge, and I use a bit of that Kevlar tail cord and knot it in as tight as I can to hold the legs in. And it works brilliantly.
You see that on old buildings where they have a cable trying to keep it.
Yeah, exactly. Yeah. It's the only solution I found to making these.
Some Kevlar string, just wrap it right around the feet.
All right. Andrew, do you have anything to add to this bridge placement?
I don't. I concur with them. I don't really change bridge position.
Well,
so
I would put in just for the record. You know, one of my teachers was Carl Becker, and his main adjustment was tapping the bridge east-west. He did not move the soundpost very often, and he did very fine adjustments, and he had a very idiosyncratic way of doing it. He would just pluck the D string, and I don't even know exactly what he was listening for, and then tap the bridge sometimes very lightly with a really tiny ruler. And they're and also little tweaks of the tail gut and things like that. And they're real adjustments, but they're almost in the magical
real magic.
Yeah. Okay. Let me ask two questions that was submitted by the audience, because they're the same basic question. It's very specific. They wanted to know, what is the effect of narrowing the waist on the bridge? Any idea?
It's more flexible. It's darker. It's
yeah.
Well, to quote Jim Woodhouse, it's really very well understood.
Who wants to give the summary of that?
Okay.
Just did.
Well, yes.
Right. Well, if you're into it is very effective in tuning the rocking frequency, and it will darken up the bridge very quickly. If you're going to have a narrower waist, then you're probably going to need to take some mass out of the top of the bridge or something else, unless you want to darken the instrument.
All right. Okay.
Could I add?
Which leads to the next question. What do you do with an instrument that is too bright or not bright enough? Sam? Well, you already said that you like
There's
bright instruments.
no such thing for Sam.
Well, okay, no, that's not totally true because basically it is it's a matter of balance. If you only have an instrument that's very shallow or something and very brilliant, it'll be perceived very unpleasantly. So you need to fill out the sound. So if I can get an instrument full enough, it's hard to imagine it being too bright. But it can. There's also bright is, I think, an overly broad word. So I try to be. This is one of the areas where I think that acoustic awareness has begun to infiltrate the field, and in fact me a little bit. Is that for example, if you say an instrument is bright or edgy, and they tend to loop those words into one lasso, so for instance, if an instrument has high output in what we call the transition range, that can be a very unpleasant form of brightness. Whereas if it's high in the 2 to 4, that's usually a more pleasant type of brightness. So just calling something bright is an insufficiently specific term. So I would say that that often when instruments are a little rigid in some way, like either too strong a bar or too strongly wooded, they can have a lot of output in the transition hill presence region, which can be perceived as edgy, and that sometimes regrads and things like that serve to diffuse that concentration of power and move it more where you need it, up and down.
I had a concertmaster client who had a beautiful Sylvester violin, which one might characterize he characterized as a little bright. But on that fiddle, we put just like the crappiest bridge and the crappiest soundpost, and it all worked really well. So it just sort of made it less efficient than it was, and it all worked out nicely. So that's
right. I mean, in a way, it's like if you can't bring up, it's like Smiles. If you can't bring up the corners, drop the middle.
Yeah.
But it's a form of de-adjusting in a way. There's a lot of things you can do that de-adjust an instrument to make it less unpleasant, and that's a very compromised position in my view. But sometimes you have to do it. Like, what are you going to do with an instrument like that?
Yeah, exactly. Which takes us to the question: do we graduate or not? So it's a Sylvester. It's like you can't open it up, and start taking wood out. It's you have to deal with what's there. But your own instruments, yeah, you can, like you said, if there's too much wood, you can go in there.
Right.
Regraduate a little bit here and there, different bass part. So it's all happy.
Robin, do you want to add anything to this?
Oh, which question?
Well, what do you do with an instrument that is too bright, or an instrument that's not bright enough?
There are 100 ways to make a cello darker. It's happens all too easily. And usually cellos that are actually too bright, because they're too strong, you actually find they kind of lack quality, more than being, you can try and make them less bright, but even when you've done that, you get a sound that, that seems to be lacking in quality and interest and complexity. And therefore, you're looking at oh God, I can remember one that some players had invested in a French instrument, not a very good one, and it was it was like, take it to somebody who'll regraduate it for you. In the end, it wasn't a good one, but there was nothing else for it, because if there's too much wood in an instrument, it's difficult for it to sound interesting. And I made one cello early on when I was making that model, and it got you know, new instruments kind of can firm up and get brighter on you. And you know, I just looked at all the obvious places. I mean, in fact, the graduations right close to the edge in the C-bouts, of the upper part of the C-bouts on the back, really helped take the edge off that cello. And this sort of discovery about where to remove the wood on the bass bar, I think I did a bit of that. So, and of course, and there's the bridges. But as you said, and then, you know, with cellos, you know, it's more difficult to make them brighter than it is to, you know, calm them down a bit. And Belgian bridges. But the problem is that if you make a bridge with not enough wood in the head, you know, you have to be careful about losing wood out of this head, because you can get quite a kind of a superficial and uncomfortable response in your effort to be bright. The other point, just, I mean, some people might be interested in this. I'm always thinking, you know, when you're removing wood from the head of a bridge, any bridge, I'm always thinking about the moment of inertia, because, you know, this is the center of rotation somewhere here. It's the wood that are furthest from the center of rotation that are going to make the biggest difference to the brightness without reducing the mass. Because, you know, if this rocking motion is important, which I think it definitely is, we're talking about a rotating vibrational system, and we're interested in moment of inertia, not just pure mass. So if you remove mass from somewhere close to the center of rotation, it's not going to have much effect. And if you remove it far from the center of rotation, it's going to have a lot more effect. So I'm always thinking about that when I'm cutting bridges. I think that's that one.
Yeah, but to follow up on that, Robin, you said it's much more difficult to increase the brightness of a cello. So you've talked about using the bridge, but are there other tactics that you can use?
Well, you've got to, you can start sticking, you know, looking for places where you're happy to place straps on the inside of the instrument. Because, you know, or as I told you about this Mara copy, the long running prototype. So I gave it a lighter, stiffer bass bar. That's definitely a help. But yeah, you know, it's you know, I've you know, talking to other people in shops, there's you know, we don't have any problem. You know, there's cellos with great A strings are never a problem. It's the ones with weak A strings that are the problem. So, you know, I think it's a I don't know, pretty universal thing. Mm-hmm. Sam, you had Sam, Andrew, huge experience in workshops, lots of cellos that needed to be bright.
Cellos like to quip, you know, I make my money on the A string, you know.
Yeah.
Okay. All right, let's go to the last question of the day, since that's, I think, all the time we're going to have, which is how important to your clientele is sheer loudness, and what would you do to increase or decrease it? Why don't you start, Robin?
You start. Okay. So I had a few answers about this. Okay, so I once was working. We were talking about. It was actually about bows with a cellist. I went in, very, you know, big soloist, and he says, you know, clarity, depth, beauty. These are the things that we're looking for in a bow, and you know, I think, you know, that's probably what we're looking for in a cello as well. And you probably realize that that doesn't include loudness. The other thing I would say, the other note I made on this point, is that I think playability is the big issue here in cellos, because, you know, if you've got a cello and it's really well set up so that it's very, so that the playability is really high. The player can lean into, work into that A string without any anxieties about the sound cracking or any hindrance. And all of a sudden it's a louder cello because it's easy to, you can play it heavily without anxiety. And so I think that's, in, you know, from my experience, that's a really big deal. You know, some models are intrinsically louder than others, I think. So I would, you know, that's my clients, you know, choose a model before, you know, before we make them an instrument. And I think that could come into the model choice partly. But I think that, and you know, England may be different, I don't know. But it's fascinating that in a big space, it's often not the loudness of an instrument that allows it to be heard over an orchestra. It's something about the identifiability and the interest or complexity of the sound, something about the sound that is making it easy to focus on the sound of the instrument, and that's not just loudness. So I guess the answer from me is it's not the big sort of request for cellos. Yeah.
Right. Andrew?
I basically agree with Robin. I think the framing of the question is wrong in a way. It's a long-standing question about loudness, and I think would you? I sort of wrote some things down this morning. I said I was thinking of richness and what Robin was saying: clarity, richness, a kind of acoustic profile that is attractive and engaging, and engaging would probably be the most. And I thought I was thinking about it this morning. Who wouldn't want to sound like James Earl Jones? You know, that it's not necessarily a loud voice. It's a voice that's rich with fundamental sound, overtones in it. You'd rather sound like, and I was thinking, who's the most famous character of James Earl Jones is Darth Vader. Sound like Darth Vader or the Queen of the Night. So it's, you know, Queen of the Night just being raw, kind of henpecky loudness. No, that's not really what we want. We want to have sufficient loudness. If loudness is a definition, we want a sufficient, and that's a grayscale. Like every player is going to have a different level of how much volume you need. Everybody likes a violin that sounds big, you know, that projects itself. But I think thinking about it just as sheer loudness is not productive exactly. I'd rather think about resonance, like a bigger resonance, like James Earl Jones. It's like, there's a big sound that has a profile that is rich in all components of the sound that you want to listen to, that you're attracted to. You want to hear it, you pay attention to it, and the player does the same thing. The player is engaged in the sound. And I want to reinforce what Robin was saying about playability. And this goes right back to the beginning. And Sam too, about each of us plays the instrument and we put the bow on and we get so much information and so much of our engagement with the instrument is through the bow. What is the bow capable of doing? Like, how can you manipulate the string? How can you manipulate the input into the instrument, and how does it reproduce that? So a good setup is just a huge part of the sound, but the instrument has to be capable of reproducing that input in a productive way. So for me, the setup is, yeah, how does the instrument, that you have a big range of playability, but also how this goes back to the soundpost. I think the soundpost is just a critical element in the setup that releases the sound potential of an instrument. It doesn't make a a bad instrument, great, but it makes the instrument function properly. It's a mechanical function. Some of the other questions was, how do you need somebody there to adjust an instrument? No, I don't think adjustment is a taste issue. I think adjustment is totally a mechanical issue. Getting the instrument to actually mechanically pump air. There's no like player magic input into that. It's just pure machinery of the instrument. So I think getting an instrument that has a rich profile of sound is more important than just pure loudness. And getting an engaging profile, and that it plays so that you can play up close to the bridge. You want to make that high fit sound, you got to be able to play like right on the bridge. And that's where the player's ability comes in to change the input. But that would be my take on it. That it is a combination of an instrument that is a certain tonal profile and is set up to be capable of being played in many different ways, or capable of varied input.
Thank you, Andrew. And Sam.
Well, I, as usual, agree with everything that's been said, but I would amplify Andrew's point that that the terms of the discussion are misleading and narrow. That when someone says, "Oh, well, the instrument is just loud," it means they don't like it. If someone likes it, they say it's powerful. So the word that people use is already telling you how they feel about it and also what they're looking for. So basically, I would substitute when someone says it's too loud, or that it has too much of what they don't want. And what I think you need is, like, for like the richness that Robin and Andrew are talking about, you need a broad dynamic range. And so where are you going to find the dynamic range? You can find it by having an instrument that's stable and focused enough to play softly. And you can have it by having an instrument that's capable of being played with a lot of power and a lot of output. Those are the two directions in which you can expand your dynamic range. And like I said before about things being brilliant, if there's like not very much in the low frequency and high frequency and a lot in the mid range, that will be, you could say that's a loud instrument and it's an unpleasant instrument. There are instruments that that have a lot of output in the high frequency, perhaps, and not much in the mid range, that are perceived as being a little softer under the ear. But in a hall, they would have that kind of profile that stands out, like Robin was talking about, that the ear catches. So what's necessary in all these things is to be more specific about what we're talking about and have more control over all the individual ranges. And within that, if you could have a balanced sound, I don't think there's any limit to how loud an instrument could be if you could balance it and have the ability to play it soft and loud.
Yeah, I don't think anybody would turn down a beautiful sounding instrument if it had a huge voice. Like, if you have a beautiful profile and just make it like turn up the volume, but it's still the same profile, they're going to be even happier.
Yeah, but the thing is, James Earl Jones has a beautiful voice, but no one listens to Darth Vader like this.
Yeah.
All right. Well, we're at 3 o'clock, so I think we're going to end it here in the formal part of the program. I want to thank the 3 panelists for the thoughts and preparing for this session. I think we learned a lot, so let's give them a great round of applause. Thank you so much. And I have an appointment I need to go to. I don't know if people want to stay on and socialize or do whatever they want. Joseph, are you going to leave, or do you want to moderate questions? Or
I need to leave in about 15 minutes. But
because,
in the meantime,
I can leave this session on. if people want to, you know.
Sure, leave it on and we'll see. Okay.
All right. So so Joseph, you can moderate for next 15 minutes. Okay, I'm going to turn off
Okay.
my video, and but I'll leave the session on. Okay.
Oh, okay. I don't. Great. Yeah, I'll second Fen in thanking you all. It's been a fascinating session. You're also articulate and imaginative in your language. If I might put in a comment about bass bars, none of you mentioned something that would come up all the time at BSA sessions passionately. That was springing the bars. And personally, I stopped springing my bars a decade or two ago. Has everybody, or people don't talk about it with the same passion as before? Any comments?
You stopped springing your bass bars?
Yes. I mean, was it a good decision or not? I know I didn't particularly notice any difference, except that I couldn't tell the difference. I was afraid I would lose brilliance and power, but no, it didn't change it. Do you spring them anymore?
It's only what happens by accident.
No, I don't personally. I don't think there's any shame in doing it or not doing it. It's just when you change the arching a little, and it's going to come back eventually. But
Tom
it's everyone's
Crone
choice.
Tom Crone has his hand raised. I know he did a study of this.
Sure, Tom.
Hi. Yeah. Oops, sorry. Let's see. There. Okay. So years ago, I did an experiment with Bill Atwood, and we looked at 3 different bass bars. We controlled as many variables as we can, and I won't go into all the details, but we did 3 bars, one with 0 tension. Well, first the original bar, which had about 3/4 millimeter of tension. Then 0 tension, 3/4 or a millimeter of tension, and then 2.5, which was hard to do, you know, hard to get it up to that 11, you know, we had to really crank it. And essentially what we found is that the greater tension increased the amount of high frequencies that were measurable by the way we were measuring. And that's neither a criticism or a recommendation, but knowing what it does allows you to take advantage of that, you know, characteristic. So perhaps if someone was trying to increase high frequencies or increase some brilliance without adding mass, you could use a little bit of tension. But anyway, that was just what we found with one instrument, but 3, you know, controlled examples, iterations.
I remember that, and it was a very good experiment. My thinking was that when you spring it, you definitely change the shape a little. And the tension is going to go out eventually. That's what just happens with wood. So my thought was just make it to the whatever the shape is where it sounds best, and don't worry about it. But I'm not on the panel. Did Robin?
Robin, you had your hand up.
So the one point I would make about this is that quite a lot of Cremonese instruments have this cant in the front. So the rib structure slopes down from the upper corner blocks to the neck. And on a cello, that can be quite substantial. And if the cello is low arched, it is absolutely essential to put the spring in the bar there to stop the front being pulled down, because if you don't do it, you get a sort of a pre-sunken cello front. And also, well, I don't want to take away what Sam's thing, but there's this thing about the bass side of the cello keeping up with the treble side, because new cellos need quite tight posts, and if you spring the bar a bit, you're going to help it not to look too funny too soon. So it's really, for me, it's really essential in many circumstances. Yeah.
Well, that makes perfect sense if you're bending the plane of the top.
Yeah.
I never thought about that. And that's another interesting question. Does anyone do that? But I see that John Haynes-Edson you have your hand up.
Yeah, a player's perspective here. In the mid 90s, I purchased a cello for orchestra auditions from a well-known maker in New Mexico. And the cello served me great in auditions, but I know that this maker at that time was in the habit of putting tension on the bass bars. And after several years, this cello developed a very strange thing. It was almost like a recessed line over the top where the bass bar was. I never fully understood it, but when I pointed it out to him, he took the bass bar out and put in a new one and said, "Oh, I don't do that anymore." So in terms of the difference of the sound, it was slightly different. I would say the bass was maybe a little less focused with the bass bar that didn't have tension on it, but that recessing went away, which I never fully understand. Like I said.
Interesting. Sam?
Well, I mean, to amplify what Robin was saying, there is a purely, the sound will be affected, but there's physical aspects to it. Like, for instance, on depending on how flat your horizon is, and on cellos, like, the arch will go down quite a bit as soon as you put the bridge on it. I don't know if you find this, but so I've been sort of tracking, like, I've made some templates just before I put the strings on, and then checked it afterwards and say, well, I better put at least that much extra roundness in my arch to compensate for the sinking. And so I think the tension, I suspect, has nothing to do, it's not tension, it's shaping the arch. So if I would put a bar in something, I would check the arch, and if it could benefit from a little bit of pushing up, I would do that.
Yes, and Andrew, would you go along with that?
I would go along with the shape idea.
Okay.
That's the principal effect, and I think you mentioned that as well. That that would be my guess, is that it's actually changing the shape of the arch.
Yeah.
Making
Okay.
the arch function differently.
Which will change the sound.
Yeah.
Sure.
Yeah.
Potentially quite a bit, as Tom was saying.
Yeah.
Any other hands up? John, did you put your hand up again? Okay.
No, I just muted. I didn't put my hand up.
Okay, I'm not used to this moderating, so I just see one hand up for John, but anyone else have any questions, or shall we wind down? Sounds like Nathan is texting, what about inclining the bar? What do you mean by that? Is that sloping it in respect to the arching? Panelists, anyone have any thoughts? You put the bar in at normal to the plane of the ribs, or do you slant it in a little so it's normal to the plane of the arch, or normal to the arching? So it's coming that way, if I understand it right, rather than going straight down.
Personally, I incline it more to the arch, so I actually have a ruler that sort of fits between the F holes. And so when I'm fitting the bar, the inside edge of the bass bar, which is pre-tapered, touches the ruler, smoothly. So I don't know what angle that is, but that's sort of somewhere between perpendicular to the arch and perpendicular to the flat surface. It's sort of trying to follow the arch a little bit, but not super like pedantically.
Well, I'm a Canadian, and I do it right in the middle too. There's the vertical, and there's
somewhere between.
One looks too far, but actually, if you think about it, if we're talking about the static forces straight down, if you were most worried about those, it makes sense maybe to have it straight. But the plate is, after all, vibrating in along the plane of the arching, or so it makes sense for dynamic stiffening to slope it. Any others?
I assume it's all the forces are within the confines of the bar, anyways. Both the vertical and the acoustic bending are all bar is sufficiently large enough that all those forces are contained within it.
I mean, I was trying to think why it would make a difference. I mean, I do it at a kind of like you all, like tilted, but you know, depends where on the arch. Like right under the bridge, it's hard to tilt it that much. Right? So like in the broadest parts of the arch, it's more or less perpendicular to the arch. But I was trying to think, well, why do we do that? You know, so
we can fit our plane on the other side of the bass bar.
Right. But I mean, the two, that's but the two things that occurred to me is that, first of all, if you don't do that, you have a much wider gluing surface going against the top, because you're not much wider, somewhat wider, because you're cutting at a tangent to the bar. And then the other thing is what Joseph said, which is that or Andrew, I don't know who was, that the top is to some extent rotating it on some of its bigger motions. Yeah. And then yet a third thing is that, you know, when I put the bar in, I'm pretty careful about not inadvertently gluing it with a little bit of curvature. But depending on your angle to the top, that line is curving more or less. You know, like if you put,
Yeah.
Right. So if you want it straight to whatever you consider to be the most important angle, there's one spot where it's going to be, and it's not perpendicular to the ribs. Does that make any sense? I'm having a hard time describing that.
Sure.
I think so, yes.
So
George?
anyway, it's nice to come up with at least plausible reasons, even if they're not.
Well, I think we shouldn't neglect just the aesthetics. It's like, why don't we do flat top bars? It just doesn't go in somehow with the rest of the design, and there's probably there are good acoustical reasons too. But George, you had your
just wanted to point out, there's a book by Cozio that I'm sure many of you are aware of, and in an entry about bass bars, he does say quite dogmatically he likes having bass bars perpendicular to, I guess, the gluing surface of the plate. And I don't know if any modern maker who does that. But I just, you know.
Was he a maker?
No, that's he had access to a lot of instruments. He worked with
sure.
Yeah, and so I just point that out. So anyway.
I mean, I think what Joseph said is there is a lot to it, which it's unpleasing to clamp something like you feel like it's going to slide downhill. You sort of want to like address it. So, and that's not a bad principle in our work, that they should not be unpleasing.
But I do, like everybody else, do it somewhere in between. So, yeah.
Okay. Any other questions? Dennis? You're muted, Dennis.
Yeah, there. Now I'm unmuted. I have a question basically on the rigidity of the bass bar and the tension of the sound posts. Is there a balance there? Robin mentioned on new cellos, he puts in a tighter post. Older cellos, perhaps a less tight post. Any comments?
Robin?
I could. This thing about one thing I'd like to say is that I don't know, I'm sure that Sam and Andrew would probably have a similar experience. My experience is that new instruments are very springy. You know, they're all kind of wild and supple and springy, and you know, that it takes a time, and this may be also connected to some of the sort of over resonance we can experience in new instruments, and that this springiness does things do distort and settle and set. In my mind, they kind of, you know, it sets as it ages and the geometry changes. But the problem with this great springiness of a new instrument before it has distorted and set into its more long-term form is that in order to induce sufficient stiffness to achieve functionality, you need a tighter post than you would in an old instrument, which is, if you like, set. So I don't know if anybody else agrees with that, but this is my.
Could I ask you to clarify? By springy, you mean flexible or you mean stiff?
By springy, I think I mean flexible.
Trampolini, trampolini.
Yeah, trampolini.
And consequently less crisp in the bow attack.
Yeah.
Okay.
Yeah. I
Anyone
would agree
else?
with that totally. That there's and new instruments vary, obviously, instrument to instrument, how much of that springiness there is. Some instruments seem to come to that a sort of resolved place quicker than other instruments, which you just seem like, oh, I just put a new sound post in that and I got to stick a new sound post in it again.
Narrower instrument, Strad cellos settle down a lot quicker than broader cellos, in my experience. I'm going to have to go. So I'm going to have to say
thank you.
goodbye.
Thank you so much.
It's been great to be here and enjoy the conversation. It's been really fascinating. So thank you.
Thank you.
Thanks again, Robin.
Great to see you, Robin.
Cheers.
I have to go momentarily. Any last thoughts, anyone?
Well, the thing about tight posts that on once an instrument is settled, I'm adamantly against tighter and tighter posts. I think that's destructive. The benefits are short-lived of any tightening a post up. The instrument's just going to stretch more, and there's nothing to be gained there. It's not an adjustment thing. So that's my 2 words about.
We hate tight posts around here.
Yeah. Although it's like loudness. Sufficiently tight that's tight enough.
We prefer to call them firm posts.
Firm posts, okay. And once you're at that point, that's.
That actually is this is a different discussion, but like with my own new instruments, I sort of keep track of what I call post flex. Like when you put the post in there and you pull it a little bit, does it sort of like reach a point and feel pretty good? Or does it just go, wah, wah, you can feel like you could just, the point is that you want the post to connect to the top and back. Well, it's not about tight. It's about just the firmness of the connection.
Mm-hmm. Did anyone else do this? I carved my the sound post side, the FO wing a little bit under, maybe 0.5 millimeter under, and the other side a little over, so because it's going the other way. But I think of the treble FO wing as kind of the postometer. If it's getting close to level, then I know it's got as tight as I ever want to have it. And if it's sinking down, there's a good, probably a millimeter of movement you can see there. Yeah. Does anyone else pay attention to that?
Yes, but it's a good metric, but not an infallible one.
Because sometimes you'll see if you put a tighter post in, people put a tighter post in, you actually see the wing go down because the arc has no place to go. So it's like, I'm just going to, behind the bridge is just going to go higher, in front of the bridge is going to go lower. You think, it's caving in, I got to put a tighter post in, and you put another one, it just like exaggerates it even more. So
I see. So you get a sort of a seesaw effect there.
Yeah.
Anyway, I'm going to have to go as well. So I'm going to sign off.
Well, let's adjourn this. Thank you, everyone. We'll see you all in a month.
Great to see you, Sam. Bye. See you, everyone.